All right, CNT125, Chapter 7, we're looking at remote access. Remote access is just that. It allows a network admin to remotely connect to a device like a router, switch, server, and work on that as if they would be standing there in the closet with the equipment. This is unbelievably helpful when you have a network up and running and you span multiple locations. Example, think of Hacks campus, Hacks network. You have Lebanon, Lancaster, York, Gettysburg, Harrisburg. All of these have small networks in them in each campus, and I would need to work on equipment at different campuses. I don't have time to drive there, so if I set up my devices to remotely connect, I could remote into a router in Lancaster, work on it, make changes to it, log out, turn right around, log into a router in York, make changes to it, log out, turn right around, and allow me to make changes to things in remote locations. That's what remote access is all about. Really important. We're going to start doing this in some of our labs so that we can see the use of. So for remote access, one thing is I need to worry about how I'm going to get access to things. Remote access server accepts remote connections and grants access to network resources. So from a user point of view, now, I was just talking admin point of view, but if a user point of view, if you have a user that's at home and you want to allow them access to their files and resources at work, I would need to set up a server for people to get access to. Take it a step further, you're a company and you have a salesman that's out on the road all the time, you would need to allow that salesman access to resources back at the home office, whether it be spreadsheets or files or whatever, so they can be updating things and, hey, I made this sales contract and blah. You would need a server so these people could remotely connect and do their work. There is two different types of remote access servers, a dedicated server or software running on a server. Dedicated server would be something like Cisco's. They give you an AS5800 performance authentication for remote users, sure. Or I can actually have one of my servers, like a Windows 2008, 2012 server, can authenticate users to the Windows domain. So somebody at home could actually log into resources at the company office. It hits that server and says, yes, you're allowed to remotely connect in, etc. with authentication. And that's the idea they're showing you here. Home users, mobile users can access the remote access server and have access to resources remotely. And here would be users sitting at home across the internet, hit their remote access server, have access to mail, web, data storage at a company or home office kind of thing. Now, there is different types of remote access. Point-to-point, remote terminal emulation, or virtual private network. So point-to-point over a dedicated line would be something like DSL, T1 to ISP kind of thing. We're going to come back and talk remote terminal emulation in a little bit, as well as virtual private networks. So let's talk about the first one we have here. With our point-to-point remote access, we're going to have point-to-point remote access protocols, downlink protocols. These are things like your SLIP PPP and PPOE. Some of you might, and actually I'll mention this one first, PPPOE, some of you might remember from the days of having a cable modem kind of thing, DSL modem. You might have actually used that PPPoE to connect to the modem and etc. and on. So that might actually look familiar to you. The other one's up here, SLIP. This is an older, less sophisticated, doesn't have encryption and so forth, but worked on things like DSL or dial-up connections. This protocol was working so that you could get remote access to devices. PPP, this was pretty much the replacement of, can encrypt transmissions through PPP encryption, weak by today's standards, but would actually allow this remote connection. So those protocols are most likely running in the background for these dedicated lines from A to B, getting connection from A to B. And a lot of us in our dial-up cable modem kinds of days ran into this kind of stuff, using these protocols to connect from A to B. Terminal emulation, the next category, this is the one we tend to use a lot as network admins, remotely connecting from home to a server, from my workstation to a router, switch, etc. in another location. So we have two different types. We can either use command line or GUI based. Command line would be things like Telnet and SSH, which we are going to do with our routers and switches as the semester goes on. Examples of GUI based would be remote desktop or things like VNC, Join Me, TM Viewer. Remote desktop and a lot of times gets used to help people remotely work on their systems, fix their systems. I might even use remote desktop to connect to a Windows server to work on it. VNC also be used, this is a little more open source, so I'm not tied into just using Windows systems. I could use this in more different operating systems, or different operating systems I should say. We're going to use these in our lab as well, so you get a little experience in setting those up and working with those. So let's take a look at these in a little bit more detail. Telnet, this is one of the first ways you would remotely connect to a system using command line. The only problem with this one is, and actually this allowed for you to connect into a router switch, make configuration changes, that sort of thing. Provides very little security, basically a simple password, and provides no security for transmitting data. This was transmitted in clear text. So you could actually see the person's password that they sent. You could see the commands they're sending, the results they're getting, etc. So not very secure at all. And here's a quick example using PuTTY. I can actually select the option for Telnet. Port 23 comes up, and I would connect into like a router and start making configuration changes, etc. That's what Telnet allowed you to do. This is one of the first ways you would remotely connect. That, for the most part, has been replaced by SSH, Secure Shell. This does the same kind of thing, but does it with encryption. This one, actually, there is a key exchange that has to happen for the connection to work. So this one is a lot more secure in any of the commands or results I'm getting back are being encrypted. People might see it, but they have no idea it's encrypted. They have no idea what's being sent. And encryption algorithms can be any of these, depending on the programs you're using to connect. Open source versions of this are OpenSSH, and they do, and actually SSH does require that both ends are running SSH. The actual, router is set up to run SSH, and your client actually has to have SSH running so they can have the key exchange and encrypt. For a client, I can run a command prompt, a shell or command prompt at Windows and so forth, or I can use a program like GUI, a GUI program like PuTTY, GUI program like PuTTY. And it does, as we said, does require key generation. When we set up SSH on our routers, we will actually generate a key, and then when we connect to the router, we actually need to swap those keys so encryption can occur. And here, I think I even have an example. Here's PuTTY set up using SSH, port 22. When you go to connect to a device, it pops up a warning like this that basically says, hey, if you trust this device, go ahead, and you're going to swap encryption keys and have an encrypted connection with it. That's what that warning is really popping up for, or what that warning is about. Remote Desktop Protocol. This is a Microsoft proprietary protocol used by Windows systems. So a Windows desktop could remotely connect into another Windows desktop, or Windows desktop could remotely connect into a Windows server using Remote Desktop Protocol. Very handy for connecting to devices to work on them. I would do need to set up to make sure the device is enabled and allowing remote desktop connections, and then the other end would need to use the remote desktop connection GUI, if you will, to connect to it. And that does allow me to work on that system as if I were sitting there. Very handy to use, whether it be helping somebody fix their computer or remotely connect into a server and start plugging user accounts or fixing user accounts or whatever. VNC, Virtual Network Computing. This is a cross-platform thing. This is more open source, if you will. It's going to run a little slower than remote desktop. It does require more bandwidth, but because it's open source, there's many variations out there. I could connect from my Apple system into a Windows server. I connect from Windows desktop into a Linux server, Linux system into a Windows server, etc. There's more variations here that I could do. Might take a little bit more finagling to set it up, but allows me more options to connect in. Here is a Linux system set up, a VNC server running, and then using a VNC viewer to connect to it. That's what you're seeing here. That's the idea behind that one. I can remotely connect to things using a management URL, using HTTPS. Many of your homeowner routers do this. Early on, you might have downloaded a little program and used the program to access the router and work on it, etc. Most times now, if you just plug in the IP address of the router in your top URL bar, you will get a little login window. Plug in a name and password and connect to the router to work on it. And now I'm doing all my configurations through my web browser. Very common. This, a lot of times now, is an HTTPS connection, so it is at least secure. It's not always the case. In this example here, I just grabbed an example offline. It's not showing that up here, so you're not quite sure when you look at that whether it's HTTPS or not. But you're getting this kind of porter. You're putting the IP address of the device in, you browse into it. Now I can click and make adjustments or changes to my device through a web browser. And that would be remote connection, remote management of. Now, everything we mentioned up to now has been in-band management, they call it. I actually have a working connection. I have a working ISP connection. I have a working network connection to the devices to be able to Telnet, SSH, remote desktop, VNC, use the management URL. Everything has to be up and functioning, and these I can use to go in and tweak adjustments to. Okay, I'm going to add a new user. I'm going to change some ports on a VLAN. I'm going to change the DHCP scope. But everything had to be up and running for me to be able to do that. That's called in-band management. Now, out-of-band management relies on a dedicated connection, wired or wireless, between my laptop, so to speak, and that device. So I actually need to have some kind of cable or connection that goes between my computer and that device. Well, the first thing we have to key in on is my device is like, here's the front of a router, here's the back of a router. I would be looking for this console port. I also, when I start looking for them, see them on switches. I even see them on access points. This allows my laptop to plug directly into these ports to configure them as if I'm standing in the closet with them. And I would just need the cable, the console cable, to go from my laptop into it. I might need an adapter, USB adapter to DB9 into my console cable and into the router, but I'm going to have a direct cable connection from my laptop into that device to work on it. That's going to allow me, when it boots up the very first time, to start putting the initial configuration into it so that I can enable things like Telnet, SSH, an IP address that I could browse into it, etc. But I have to do this out-of-band management to get the thing up and running to enable all these other things I might use. I can also, if I need to in some instances, actually plug a modem into the aux port. That's what the aux port's for. I could plug a modem into the aux port, and then I could remotely dial into this if we're having issues. So think about it. Let's say I do have this little router at a remote place like a pumping station where they're pumping natural gas out of the ground, and I have this little router there that I'm monitoring systems and so forth, and I need to connect into it to check on it. Well, if I have problems with the ISP connection, I would need a backup. I could actually have a phone line plugged into a modem plugged into this aux port, and I could remotely connect to it if there's a problem with the ISP line. Just giving you an example. That's another example of out-of-band management. And that's what this auxiliary port is for, that type of connection. All right, we'll come back and talk file access in the next podcast.